Today we're going to be looking at solving some equations and inequalities graphically. The first thing we want to do is take a look at example 1, and in this example we're just going to check out what a particular function looks like using several different viewing windows. I'll give you the three windows that we're going to use. We're going to use first of all an x minimum value of -2 to 2 and a y minimum value of -2 to 2. Then after we've looked at that, we're going to change the windows for x minimum value of -4 to +4, same thing for y. And then the third window we're going to look at is going to be a window for x values from -10 to 10 and for y values from -5 to 30. And we're just trying to get an idea of which one is going to give us a better picture of what's actually going on with that particular equation or that particular function. In example 1, the first thing we want to do is look at a graph of the equation y equals x squared plus 3, and we want to check out three different viewing windows to see which one gives us the best picture of this particular graph or this particular function. So what we're going to do is we're going to take a look at our calculators, and I'll try and get this in the screen here so we can see the buttons. As we want to turn it on. And again, the first thing that we need to do is to enter in this function. We push the y equals button, which is here in the top left corner. Get rid of anything that's there, so just push the clear button. And then we want to enter in the function x squared plus 3. Now once we've done that, the first window we're supposed to look at is a viewing window where the x minimum is -2 and the x maximum is +2. And also the same thing for the y values. So we push the window button here right next to the y equals button. As you can see, that's not what the window is set at, so we're going to have to change it. So for x minimum, we put in negative. Make sure you use the negative key and not the subtraction key. -2. And we can hit enter to go down to the next one. We'll use 2 for the x maximum. For the x scale, we'll just use 1. Again, for the y minimum, -2. For the y maximum, +2. So again, we need to hit the window and then change those values to be the window that we want to look at. -2 to 2 in both the x and the y values. Then we just hit graph, and let's take a look at our function. Notice that we have a problem. We can't see any of the function using this window. All we see is the axes. So we're going to take a look at a different window. Since we couldn't see anything on that window, we want to change our window again. So again, we're going to push the window button. We're going to change our window to, this time, x minimum of -4, x maximum of 4. And then going down, and I'll let you watch it on the screen there, the y minimum will be -4 again, y maximum will be 4. Then we'll hit our graph button, and notice this time we see just a little tiny piece of the graph. So we're still not getting a very good picture of what this graph looks like. We do know, since it's quadratic, that it is going to be a U shape, and we can kind of see where it is. But let's take a look at our third window. In our third window, we want the x minimum value to be -10. We want the x maximum value to be +10. The y minimum we want to be -5. And the y maximum we want to be 30. Since we've got a very large range that we're looking at for y, let's change our scale for y to going by 5s. That'll give us not so many dashes on the y-axis there. So now as we graph it, we get a much better picture of what's going on. In fact, we could even shrink down the x values a little bit, but we're getting a much better picture of what's going on. This thing goes up very, very quickly as we look at that. So in this case, what we're trying to figure out is that it's very important many times to adjust your window to get a good picture of what a graph actually looks like. In example 2, we want to look at two different functions and see if they intersect. The first function is y equals 3x squared minus 6x plus 1. The second function we want to look at is 0.23x minus 2.25, and we want to use the viewing window using the x values from from negative 1 to 3, and then the y values from negative 2.5 to positive 1.5. And the question is, do these functions intersect?
In example 2, we're supposed to find out if these two equations intersect, and they want us to start out by looking at this window. So we're going to set the window first, where x is negative 1 for the minimum and goes up to 3, and y is negative 2.5 for the minimum and goes up to 1.5. Again, to change the window, we push the window button, which is directly to the right of the y equals button. Now we need to go here and enter in these functions, 3x squared minus 6x plus 1. And the second one is 0.23x minus 2.25. There's the first one and the second one. Now as we look at that, it looks like it probably intersects around the point where x equals 1 and y equals negative 2. But it's not a very good picture. It's not very close, and it looks like it might be just touching barely, so we want to zoom in on that a little bit. So I'm just going to use the zoom key. I'm going to push zoom, which is right at the top in the middle, and I'm going to zoom in. And then I'm going to move my cursor down here by this intersection, or where it looks like it intersects, and I'm going to hit enter. So here's a little bit better picture. Still looks like it probably intersects, but still certainly doesn't intersect very much. Now, if I just hit enter again here, it will zoom in one more time for me. Okay. Zooming in twice, we see that these two functions actually do not intersect, and so therefore the answer to our question is, do they intersect? No, but you have to be careful, because if you're not zoomed in far enough, you may not be able to see it. Now going back to a standard window, zoom 6, again in this point it probably looks like they're going to intersect. We can use second trace again. And if you look at option number 5, we can find the intersection of two curves. So I'm going to select number 5 here, hit enter. Notice that it asked me for my first curve. Now right now you can see the cursor is on that parabola. And I just need to select the parabola as my first curve. So I'm going to hit enter. Notice that now it asks for the second curve. It already jumped down to the line. So I can just hit enter again, and I don't want to guess, just like before. It will try and find the intersection, but notice what happens. It gives us an error, no sign change. That means the calculator can't find any intersection there. And so one of those two ways, either by zooming in a lot or by using the calculator to find the intersection, we find out that there is no intersection between these two functions.
After zooming in enough, or else using the intersect feature on your calculator, we find out that these functions do not intersect at any point. In example 3, we want to graph the function, or the equation, x squared plus y squared equals 1. And the question that we're asked is, how can we graph that equation using a graphing calculator?
Since a graphing calculator can only graph functions, we actually have some issues with graphing an equation like this. If you remember, this is the equation of a circle. This circle has a center at point 0, 0, or the origin. It has a radius of 1. But we cannot graph this just by plugging it into a graphing calculator. So what we have to do is we have to solve this equation for y. So to do that, you have to get the y by itself. We have to subtract x squared from both sides. That gives us y squared equals 1 minus x squared. Then our next step to get y by itself is to take the square root of both sides of the equation. And when we do that, we get y on the left-hand side. On the right-hand side, because we are taking the square root of both sides of an equation, we have to remember that this gives us positive square root of 1 minus x squared and negative. We have to put in the plus or minus. And if we graph those two, y equals the square root of 1 minus x squared and y equals negative square root of 1 minus x squared, we will get our entire circle. And I'm going to show you that. Okay, just a reminder, as we enter this in, we need to type in the square root, which is second x squared, 1 minus x squared, and we need to type in negative, or the opposite of that. You use your negative button, and then you type in the same thing. Square root of 1 minus x squared, close your parentheses. Just to get a standard window of this, you can go zoom 6, and I've got some extra stuff on here, so let me get that off of there. Okay, and if you look at that, notice it gives us a picture, but it's not a very good picture. It's not very big. I'm going to go ahead and zoom in on that using the zoom and then zoom in button. And let's take a look at it now. Notice that it doesn't really look like a circle. The reason for that is that the calculator has a screen that's a rectangular shape. And so if it has the same distance covered from left to right as it does up and down, it gives us kind of an oblong shape. If we want to fix that, we can use the zoom key again and go down to number 5, which says zoom square. And when I hit that button, you'll see that we get a much better picture of a circle there. And that is how you graph an equation that is not solved for y. You have to solve it for y, and then you graph however many parts of that equation you need to get it graphed on your graphing calculator.
As we discussed, you have to enter both. You have to solve the equation for y, and then you have to enter both of these functions in order to get the complete circle. Now, to solve an equation by graphing, the first thing that we want to do is set the equation equal to 0. So we're going to get everything over to one side of the equation, and then we're going to graph that function y equals f of x and find the zeros of the function. We're going to take a minute to solve example 4, A, B, and C, and then also example 5, graphically.
As we work on example 4, we want to find the solution of several equations. The first one is x squared minus 4x plus 2 equals 0. So we're going to type that in, x squared plus 4x plus 2, minus 4x plus 2. And we don't type in the equals 0, we just set that function equal to that. So zoom 6 again takes us back to a standard screen, and this is what we're going to see. Now the question that we have to ask is, when does this function actually equal 0 or have a value of 0? And that occurs in this area right here and also in this area right here. Now it's not very easy for us to tell what those exact values are, but we can let the calculator do that for us. And here are the keystrokes we're going to use for that. To let the calculator solve this for us, we're going to go, if you look at second trace, that is how we have the calculator calculate things for us, and we want to use number 2 because we want this to find the zeros for us. Now at this point, we have to tell the calculator where to look, because as you can see, the calculator asks us for a left boundary. So if I'm going to look, first of all, for this solution, I can let the left boundary equal anything to the left of this point right here. So I'm just going to choose to let x equal 0. Then when I choose a right boundary, I'm going to choose that one. Again, anything to the right of that point. So I'm going to choose x equals 1. All that we have to do on the calculator for this is, since it's asking us for the left bound, we just type in 0 and hit enter. For the right boundary, we type in 1 and hit enter. And then it asks us if we want to guess. We don't want to guess, so I'm just going to hit enter again. And we find out that one of our solutions is 0.585. We'll just round it off that far. And this is approximate. And then we can find the other solution. Again, we need a left boundary. They're going to ask us for that. So 1, 2, 3. We can use 3 as our left boundary. And we can use 4 as our right boundary, because we want to find something around that point. So again, we're going to hit second, trace, go down to number 2, which is finding the zeros. And for our left boundary, we're going to choose 3. So you just type in 3 and then enter. It asks us for the right boundary, so we're going to type in 4 and then enter. And again, I don't want to guess, so I just hit enter again. And we find out that the other solution there for x values, approximately 3.414, 2 if we round it off to 4 decimal places. So that's the first part of this example. There's your 2 answers. That's for part A. In part B, we're using a different equation. So we're just going to go y equals and change this value to x squared minus 4x plus 4. That's the second equation we're finding the solution to. When we graph this, we've already got a standard window. Notice that it looks like it just comes down and touches the x-axis. Now, when we want to find this solution, we're going to do the same process. So, again, just to show you, we don't have to be right next to this value. I can still let my left boundary be 0, and I can even let my right boundary be 7. Because if there's a solution, it's going to be somewhere in this area. So that will be between 0 and 7. It'll also be between 0 and 6. It really doesn't matter, just so that we have a point to the left and a point to the right. So second trace, down to 0. Left boundary, I'm just going to enter 0, enter. Right boundary, I'm just going to choose 7 and enter. I don't want to guess. So it finds out that this solution, now notice this is a little bit of a pixel issue, but notice our solution here is actually x equals 2. That's an exact value, even though it does have this 9 at the very end. That's just a calculator issue with the pixels. The way it's programmed, it finds a solution a little bit differently. So that's our solution on that one. Now for part C, we need to find the solutions of another equation. We've got x squared minus 4x, this time plus 6. Now some of you may guess already what happens when we graph this. That graph moves up 2 more spaces. The problem is this graph never reaches a value of 0. The y value is never 0, and that's what we're looking for when we're looking at equations. We want to find out when does the y value equal 0, because that's going to make the equation equal 0. So in this case, if there's no solutions, or if there are no points where it intersects the x-axis, we find out there are no solutions. And that can happen. So with a quadratic like this, a parabola, you can have 2 solutions where it intersects twice. You can have 1 solution if it intersects at the vertex. Or in this case, when it doesn't intersect at all, you can have 0 solutions.
As you can see in example A, we get 2 solutions because the function intersects the x-axis at 2 different points. In B, the function intersects the x-axis in just exactly 1 point. And then in C, we get no solution because there is no intersection between the function and the x-axis.
For this problem, we're supposed to find the solutions of 5 minus 3x equals 8x minus 20. This is easy enough to do algebraically because this is just a linear equation. But in order to solve it graphically, what we want to do is move everything over to one side of the equation. It doesn't matter which side. So in this case, I'm just going to move everything to the right side. I'm going to subtract 5 from both sides, and I'm going to add 3x to both sides. That's going to give us 0 on the left-hand side, and it's going to give us 11x minus 25 on the right-hand side. This then is going to be the equation that we're going to graph to find the solution for x, or find the value of x. Now, we can go ahead and finish solving this easily enough. Algebraically, we would add 25, and then we would divide by 11, and we'd find out that x is 25 over 11. But let's go ahead and solve this graphically. Again, we're going to solve this equation, 11x minus 25 equals 0. To solve that, and that is going to stay in the screen a little bit, but we'll go ahead and hit y equals, and we want to type in 11x minus 25, graph it. Notice it's just a line because it's linear. I'll get that in a minute. We're going to find the zeros, second trace, and we find the zeros. Again, left boundary, I'm just going to choose 0, and then I'm going to choose 5. I don't want to guess, and I get 2.27.
In example 5, we can see that the solution to our equation is going to be x equals 2.27 using the method that we described above. In example 6, we want to use the same method to solve this equation on the interval from x being 1 to 6. So we're only looking for solutions in that area. And the equation we're looking at is x cubed minus 6x squared plus 9x equals the square root of x.
In example 6, we're supposed to solve the equation x cubed minus 6x squared plus 9x equals the square root of x. Again, we want to move everything over to the same side of the equation, so we're going to type in x cubed minus 6x squared plus 9x minus the square root of x. And then, again, to go back to a standard screen, we hit zoom and 6, just in case we've changed the screen at all. And so this is the picture that we get. Now they tell us that we're only supposed to look between 1 and 6, the x values between 1 and 6 for our solution. So I'm going to change my window, and I'm going to change the x values from 1 to 6. And since I only care about when when the y values are close to 0, I'm just going to go from negative 5 to positive 5 because I don't really care what the whole function looks like. I just want to know where the zeros are. So now when I graph that, notice I get a nice gradual curve. It looks like there are 2 zeros. And so again, we'll use the process of finding the zeros. Remember, this point was 1, 2, 3, 4, 5, and 6, because that's the region we were looking at. I'm going to choose between 2 and 3 to look for that solution, and I'm going to choose between 3 and 4 to look for that solution. So again, to find these, we're going to push second, trace. We're going to go down to number 2 to find the 0. I'm going to choose 2 for my left bound and hit enter, 3 for my right bound and hit enter, and then I don't want to guess, so I'm just going to hit enter again. And we find out that the x value here is approximately 2.18. The other x value, we're going to go through the same process. Second, trace. We go down to number 2, which is 0. And we choose a left boundary of 3, enter, a right boundary of 4, enter. And again, I don't want to guess, so I just push enter again. And we get the x value here is 3.72 approximately. By the way, for those of you wondering, that was my wife calling, but it's not her telling me that the baby's coming, so we still have time. So those are our two solutions for this equation that are included in the boundaries that they give us between 1 and 6 in that closed region.
And that does match up with our solution 2.18 and 3.72. In example 8, we want to solve an inequality. This one is a little bit different because, again, we're going to be looking at when is this equation less than 0, and when is it more than 0. Those are the things we're going to look for. To solve that inequality, we're going to move everything to one side of the equation and then find out where this statement is true.
In this next example, we've got an inequality. So we want to know when the left side is less than the right side. But again, to do this problem, we want to get everything over to one side of the equation, or of the inequality. So we're going to subtract 2 from both sides. And we're also going to add 1.4x to both sides of this equation. So now what we have is 3.7x squared plus 2.7x minus 3.9 is less than or equal to 0. We're going to take a minute to graph this. We're just going to graph it as an equation. So we're going to type in exactly what we see. 3.7x squared plus 2.7x minus 3.9. And let's take a look at that graph. Zoom 6 gives us a standard screen. So we're looking for the spots where this function is less than 0, or when this function is negative. Notice that in this area right down here, that's when this function has negative values. Okay? So what we want to find out is, what are the x values that make that happen? So in order to do that, we need to figure out what is this point and what is this point. So we go through the same process of finding the zeros. We're going to use this as our boundary here and here, and then we'll use this as our boundary here and here for that point. So second trace, we'll find the 0. Left boundary, I'm going to use, what did I say, -2, enter. Right boundary, -1, enter. And I don't want to guess, so I find out, and you maybe can't see it very well, but we get -1.45 approximately for our right boundary. Since this is an or equal to problem, I'm going to write it out like this, even though this is an approximation. For the right side, the right end of our interval, we're going to do that process again. Second trace, we're going to find the 0, and we want to use from 0 as the left boundary to 1 as the right boundary. And we don't want to guess, and we get 0.724. Again, I'm going to round that off, 0.72, and since it is a greater less than or equal to, this interval from when x equals -1.45 to positive 0.72, this interval right here is the time when that inequality is less than 0, less than or equal to 0. If you were doing greater than or equal to 0, you would just look for the spots where the function is above the x-axis, because these are the positive function values, these are the negative function values.
Your assignment for this section, 2.3, is on page 177. You're going to have to do a lot of this in class because it is going to require the graphing calculators, but you will have the remainder of the class today and then tomorrow's session. But it's page 177, numbers 1 and 2, 7, 8, 24, 26, 38, 40, 42, 46, 49, and 51. So you can go ahead and get started on that. Again, tomorrow, those of you who are good using the graphing calculators may need to help some of those who are not as skilled at that. And have a good remainder of your day.